For the first example, we have 1.5 liters of 10% dextrose in water, and this IV is to run from 1,300 to 1,900 hours using equipment that has a drop factor of 15 drops per milliliter. So before we're going to look at whether the IV is running ahead or behind schedule, we're going to find out the flow rate that's specified in this situation. And we'll notice that the 1,300 to 1,900 hours, that would be like from 1 to 7 o'clock. So that would be 6 hours of time. And this 1.5 liters, hopefully you'll remember that that would be the same as 1,000 times more, 1,500 milliliters. And so when we want milliliters per hour, we'll look at the units and say, hey, let's put our milliliters on top and our hours on the bottom. And then when we divide these, we'll get milliliters per hour. We could estimate this and say 6 goes into 15 two times, so this would be about 200. And if we calculate this out, I believe this comes out to be exactly 250 milliliters per hour. So you divide the units just like you divided the numbers. Milliliters, the line is per hour. So we'll record that. 250 milliliters go into the patient each hour. All right, now because this is a gravity feed, we'd also want to know what that flow rate is in drops per minute. So we can keep in mind we want to end up in drops per minute. We could start with 250 milliliters for every 1 hour and notice, oh, we want minutes on the bottom, so let's replace 1 hour with the equivalent number of minutes, 60 minutes. And all right, then we realize, oh, I've got milliliters per minute if I divide it out, but I want drops per minute. So we're going to multiply by the drop factor of 15 drops per milliliter, and that will change the milliliters into drops. For each milliliter, we have 15 drops. So we don't actually have to figure out how many drops that is. That's already in the equation here. But if we look at our units, we've got drops now on top and minutes on the bottom, and that's what we're after. So now we can multiply the numbers horizontally, 250 times 15, and we don't have to worry about multiplying by 1 on the bottom, because that doesn't change anything. So we're dividing by 60, and this will be drops per minute. And we can say 15 goes once into 15 and 4 times into 60. And then we'll say 4 goes 6 times into 25. So it should be about 60. And I believe if we calculate this, we'll come up with 62.5 drops per minute. And we'll round this to the nearest unit, so we'll say 63 drops per minute.